Hello there, it's Jay here from Jay's Vintage Junk, and today I thought we would have a look at this. Now what we've got here, it's a bench power supply, but it's not like your normal bench power supplies that most of us are familiar with, like that thing there, which produces about 30 volts to up to about 2 amps. That one, it's dual channel, so it can do 2 lots of it. It's quite a nice fancy bench PSU, that, which I really do need to repair at some point. It has died a death at the moment. This is something slightly different. This is a high tension bench power supply. This is designed for working with valve circuits. So basically what you've got is you've got a centre tapped 6.3 volt output there. So you've got 3.15 volts and 3.15 volts with a centre tap. So you come off them, there's 6.3 volts AC. And that's to drive your up to 3 amps, and that's to drive the filaments in the circuit you're working on. You then have a variable HT output here, which will go from 0 up to 500 volts. So it can produce up to 500 volts DC for powering whatever valve circuits or high voltage circuits you're working on at the time. So yeah. That's basically what we've got here. Now, I picked this up a few years ago at a car boot sale, and I know I paid under a tenner for it. And I haven't actually done anything with it since I bought it. It's been in storage. But I'm working on a project at the moment which does involve fairly high DC voltages. It's a little, do you know these little crappy Chinese? Oh, I've got one in here. Yeah, these things, little cheap phono cartridges. I'm making a little circuit up to be able to allow the one valve wonder record players. They were cheap record players from the 50s and 60s that literally just had one valve in them, and they used a very high output cartridge to drive it. And the cartridges are horrendously expensive for them, and the record players in most cases aren't worth very much. But I mean, these, I pay £1 each for these. And if I could get them to work in them cheap record players, it'd be a real useful thing. It'd save a lot of old record players that otherwise just get broken up for parts. Oops, the wind's getting up a little bit. I think we're going to have a storm tonight. It's blowing all the papers around in my attic. It's still quite warm. I've got to have the window open. I just shut the window down a little bit so it'll stop blowing my papers around. Alright, there we go. That might be a bit better. Anyway, where was I up to? Yeah, so I've been fiddling with this circuit, and I've been using my own little homemade HT power supply that I've had since I was a teenager. The only problem with that is it's only got a couple of fixed voltages on it. It gives out like 250 volts and 350 volts at various amounts of smoothing on it. And I wanted something that I could really control while I'm working on this project. So I remembered I bought this thing, so I dug it out of storage. And I thought we'd have a look at it today and see if we can get it up and running. Now, it's a Solatron unit, this, who were a very, very big maker of oscilloscopes and test gear back in the day. Right back in the day, we're talking 50s and 60s. I think this probably dates to either the very late 1950s or the 1960s. And it's actually a piece of military equipment. This, if you look here, it has a military designation on it. It has the little military arrow on it, and it's a CT397 for anyone that's into military stuff. And it also has an MOD record sticker on it there, so it's definitely a piece of ex-MOD hardware. And that's the first problem. Well, we've got 2 problems with it. First problem on the front, if we can see, is it does have a broken connector there, and I can't just leave that floating around because you've got a potential of that shorting on something and burning one of the windings out on the transformer, so we need to address that there. I've got an idea what I might do with that, to be honest. It won't look too horrendous. And our next problem, being this is a piece of military equipment, is it has military power socket on it. And I do not have, it's not a Bulgin, it's not an IEC, it's nothing like that. It's something that's unique to military equipment, and I have come across kit with this stuff on it before. And then LCD monitors that I was mucking about with a few months back, which I will get back onto at some point. They use these type of connectors for the power and the video in. So yeah, it is like a special military standard, which I don't, like I said, I don't have any leads for. So what I've come up with is, I was having a look in the garage and I found some of these. And these are stuffing glands. And what I thought I'd do is, I got this the other week. I was helping my tenant put a new washing machine in, and they'd bought a new washing machine, and I helped them plumb it in, and threw the old one outside, and I cut the lead off it. So we've got a nice, decently rated lead here with a 13 amp plug on the end. I'll probably put like a 3 or a 5 amp fuse in it for this to run this thing. It doesn't need a 13 amp in it, but we've got a nice decent plug there. So what I thought we'd do is we'd crack into this. We'll take that military socket off, fit that stuffing gland in there, and wire the cable up so it's just got a direct cable coming out of it to actually run the thing. We'll repair that broken terminal on the front, and we'll give it a whirl and see if the thing actually works. And you can have a look inside it as well and see what a rather well-built piece of kit this is. And that's the first thing we'll do, is we'll get the case off. And there's no mucking about with a screwdriver on this military kit. I think the thought squaddies must have a bit more sense, because literally you get in it by just they're just finger screws, just like nail screws on the sides of it, and one on the back. We'll take that out, and we're in. And you can tell straight away this thing just screams military. Look at these transformers, potted transformers. It's either a HT transformer or an LT transformer, or that's combined HT and LT, and that's a choke. I honestly don't know, because I don't have a circuit diagram or anything for this thing. We're just going to have to see how we go with it, and figure it out the best we can. Which, yeah, we'll do that. We're daft enough and sensible enough to be able to do that. We've got a huge capacitor bank here. We've also got a humongous capacitor bank here, and these will be all military grade oil filled capacitors. They're going to be 100% bomb proof, these things. I've come across them in the past. I've never ever found one that was faulty. It does look like it's had new valves in it at some point, because these haven't got the military designations on them that it would have had originally. They've had a CV number on them, like these two. Should be CV428s, and they've got a 5B-254M in there. Which, I mean, that's fine. Someone's, obviously this come out of military service a very long time ago, and someone's replaced the valves, and they've just replaced them with the civilian equivalents. Same here, this is the rectifier stack for it, and we should have CV2235s in here. And we've got EY84s, which are they're a diode rectifier, basically. I think they're a single diode. They're not a bridge, I don't think. I think they're just a single diode with the top cap as one connection, and so I think that's the anode, and the cathode's down there, and then you've just got a heater winding on them. But they are a HT, you know, they are good for high tension, and we do have 3 of them. I wonder if they're running parallel, maybe. And that's pretty much all we've got on top. We've just got the meter movement down there, and the offending broken connection down there, which we need to get to. I think what we're going to have to do is flip it on its back, take this back panel off, and hopefully that'll get us access to the mains connector there, and we may be able to get in and repair that broken connector down there. So let's get the bottom off it. So I do like some of this old military kit. The only problem is it weighs a bloody ton. I actually had to get my neighbour, I managed to spot him just before he went out, and I managed to get my neighbour to help me get this up into the attic, because I just can't lift it at the moment. I took it from my storage unit into my van, and I had to use a wheelbarrow then to move the thing. And I managed to get it in from there to the house, but again, That was very slow steps, but there was no chance of me getting it up here. Fortunately, it can stay up here for the moment, and then I'll have to have some help to get it back down out of here. There we go. Last one. There we go. Let's have a reveal. Look at that. Now that screams quality. Just let's get you up there and let's just zoom you in a little bit so you can have a quick look at this. Have a look at that there. You see it's all loomed. Everything is loomed in here. One capacitor there. I wonder if it's got a date on it. It seems to have absolutely no sign of any leakage whatsoever. No bulging. They're all stuck on with them. I think they're all conformally coated as well. And they've all been sprayed to I don't want to try and risk forcing it out to. I was just seeing if I could see a date on it. But it's a 0.1 microfarad rated at 1000 volts, so you can't see it, can you? This little baby down there, so it's 0.1 UF rated at 1000 volts. I don't expect there to be any issues with it. Like I said, you very rarely find them in them type of capacitors. This is what we want to look at here, this broken terminal on the front. We need to address that, like I said, because I don't want that to risk shorting on anything. So what I think we'll do is we'll unsolder the wire from it, take these nuts and bolts out and actually take it out and see what's what with it. Just adding a little of extra solder to get the joint to flow, and then we should be able to hopefully. There we go. It's out. Don't want that to touch because that'll still be red hot at the moment. There we go. Look at the thickness on these cables as well. I mean, they're only the HT filament's only rated at 3 amp, and this stuff's substantial. Just sort of see if we can get a little bit of a solder off that, so I can get the get a pair of pliers on there or something and get them nuts off. Hopefully we can get these to come off fairly easily. I have to hold that on the back end of these pliers, like that, and hopefully we can get these to crack off. There we go. Dear me, these are stubborn little things. That's the first one coming loose, I think. Grab that. Quick turns. Dear me, these are being tricky. What's causing the problem. It's the old flux and whatnot underneath, and varnish that's the army like to apply to everything. It's kind of gummed the threads up a little bit. Nearly off though. And once we've got the first one off, the second one should come off a lot easier. There we are, that's the first one off. I think the second one's just going to be a bit awkward at the end here, but most of that comes straight up. Yeah, it's going to be a pain. Right, let's see if we can get in this way. The problem is you can't just hold it because the back of the actual terminal that the bit you normally see is spinning as well. So you have to keep your finger on that to stop that from spinning while turning. Turning the knot. I might be able to do now. Just grip it like that. That's it. That'll get it out now. I can get a good grip on it. There we are. We're out. And what's happened with this? It's obviously it's taken a bash. And there should be an extra little insulating thing like that that goes on the other side of it, that goes basically in there, in that gap there, and it's no more, it's gone, which is a bit of a pain. And there's not a lot I can do to actually repair that really. So zoom you back out again, so oops, you can see a bit better what's going on. So what have we got options of? What I do have, I mean it's not the same, I don't think that's going to work. No, it's too small. I was planning on seeing if I could fit that in the middle, replace the middle one so they're symmetrical, and put that on there, but I'm just wondering whether I may actually have one of these on some scrap stuff down in one of my stores. So just bear with me, and I'm going to have a quick look in my stores and see if I've got something that I could possibly replace this with, and we'll take it from there. So back in a second. Okay, I'm back, and I'm pleased to say I've got one. Actually, what I did is I found this thing up in my junk. It's a little homebrew amplifier that someone's made. It's absolutely lethal inside, and I'm going to do something with it. But for the moment, I've pinched one of them. They were the speaker outputs on it, and they're exactly the same. But it is quite interesting, this thing. I don't know if you can spot in there. Rather familiar, just a little teaser. I don't know if you can see it. A rather familiar maker's name in there. Right in there. I don't know if you can spot that. I'll leave that as a little teaser, because it's a little one of our favourite computer brands related pieces of equipment, this, from well before they did anything to do with computers. So I'll leave that to one side. Anyway, for the moment I've pinched one of the connectors off it, and in fact all I need off it is that bit. Okay, it's black, not white, but it'll do. At the moment, so I've not got a huge amount of time, I am just going to stick it, I'm going to stick it here. So it will look wrong, but at least we'll have the unit functioning. Maybe in the future, when I've got more time, I'll go in and I'll make it in the middle, or I'll find a white one. But for the time being, at least we can get the unit functional again. So that basically goes through there like that. We'll have to hold that in place. This is the tricky bit, is getting all this to line up. Well, basically we'll put that through there, back like that, and we use the white bit off the back that goes through like that, and get this thing to line up in the centre, there, like that. Put the washer on. This is the tricky bit, we've got to get it all to line up and get these nuts back on here as well. There we are. And we need that to go right in the centre, like I said, it centres, there it is, that's in. Then we can do it up. And that the bit of the bit of plastic on the front and the bit of plastic on the back basically hold it isolated from the metalwork round it, so that's floating between them. In fact, we can just we'll just, that's a bit tight, we'll sort that after. We'll just test that. We'll just get a where's the test meter gone? There it is. Just set that to continuity, and we'll just go between chassis and that, just to make sure, yeah, that's okay, that's not touching anything. Just go between everything else, just a few things. Yeah, no, that's definitely isolated, so we're happy there. So now we can put the second nut on it. Lock that down so it can't move. And we can resolder the ridiculously thick wire onto the top of it. Could really do with a bigger bit on my iron for this, but it should do it. There we go. Yep. In fact, just add a tiny bit more solder just to make absolutely sure. There we are. There we go. So that now, that's the first fault fixed. So I'm a bit happier about actually powering it up. So that comes on to the next one, which is we need to replace this with that piece of flex and that grommet. Oops. We'll just take you up here a little bit. Zoom you in. So this is what we're dealing with at the moment. This military connector. Now these need a special key to undo them and do them on, but fortunately you can cheat them fairly easily. You just get a screwdriver, put it in the key and give it a tap. You can tap them enough so they come free, and we can remove that. Now, I won't throw this away, because if I do ever come across any of the military socket plugs that plug into this, obviously I would install one and then put a normal cable on the end of that. And with that in mind, what I'm not going to do actually is I'm not going to rip any of this wiring out. I'm going to join the new wiring onto it with some heat shrink. Just so if I can revert back to this, it's easy. I can just take my bodged cable out and replace it with the correct cable and solder the wires back on. I don't have to modify anything in here. It's like it's too good really to do too much modification to. I will probably take that earth off from there. And I'll bend that out of the way, and I will connect the cable's earth straight to that solder tag there, and that's not going to cause any harm where it is. Let's get these rubbers, and these aren't heat shrink. This is actually rubber, little rubber boots that they used to use. There, so we've got our live and neutral, red and black. It's the old colour code, so you can tell there is some age in this thing. And there's our earth point up there. So let's prepare our cable. Let's see what fuse this has got in it at the moment. We'll probably have to change that. Yeah, it's got a 13 amp fuse in it at the moment, so we'll swap that. Let's see if I've got one. Yeah, we've got one of them there. We'll put, there we go. I've got a 3 amp fuse in there now. Just snip this. We don't need too much because I literally want to come in there and there, so just snip a little bit of the insulation. There we go. Yeah, definitely 3 amp fuse is more than enough if you look at the diameter of that cable. I mean, it is fused as soon as it gets in here as well. It's quite a well fused unit by the look of it. Got a mains fuse on the back there, and then it's got a fuse on the high tension side as well. Don't think it's got a fuse on the low tension. Oh yes, it has. It's got a fuse on the low tension side, on the AC side for the valve filaments as well. So we'll just get them tinned up. There we go, they're tinned up. And we will get this grommet, this stuffing gland as they call them, will go in there. In fact, yeah, I think the washer can go on the outside. You can get it to sit square. Let's sit down there. Sit down there, you little bugger. That's better. That goes in there like that. Screw that in. That's good and tight. We can take our new cable through there. It only needs to go through a little bit. We crank down on that like that, and that crushes a rubber in there, and that actually locks the cable in place, so it can't pull out. Just as an additional, because it is a little bit thin for it, just as an additional precaution, I'm just going to take a couple of cable ties. Pull them really tight. Snip the excess off. I'll put 2 on just to be super safe. Like that. And even though that can pull up there, it can't pull through. That's it, that's as far as it can pull now. In fact, that's worked out really well. That's just got the cables just where I want them. So that's good and solid. Now we'll solder the earth onto the earth connection there. Just put a little bit of extra tin, a little bit of extra solder on. Like that. That's set. There we go, that's good and solid there. Now we just want a little bit of heat shrink, and we're going to heat shrink these connections so they're absolutely safe. So where's my box of heat shrink gone? Where's my heat shrink gone? There's one box of it. I don't know if there's enough in here though. No. Where's my other heat shrink gone? Why does it always disappear as soon as you need it? I was only using it the other day. That's not it. I know Andy says he has the solder fairer that comes and steals his solder. I think I've got the heat shrink fairer. Comes round and moves my heat shrink whenever I'm needing it. Just bear with me a second, folks. I'll be right back as soon as I've found where my heat shrink's gone. Okay, I'm back and I found it. I added the ZX81 on top of it, like you do. Right, so let's find some suitable heat shrink. I'll just cut a piece of that off, not that size. That's just right. And these can go over, so we'll put the red one over the live. I'll just snip that wire down a little bit, 'cause that's a little bit on the long side. And we can join them two together. Like that. That's a nice solid connection. We'll put the heat shrink over that. And we'll do the same with the neutral. We'll bring that round there. I'll put the, oops, I'll drop the heat shrink. Put the heat shrink up there like that. We'll bring these two together. Like that. And put the heat shrink over that. And we'll get the old hot air out to shrink that down. And you don't have to do it this way. I lied, or you can use a side-use soldering iron, but it does give a much neater result if you do it with a heat gun like that. There we go. And there's the new mains lead, safely connected. It's not going to pull out. It's to the right wire in there, and it's earthed properly. So I think what we'll do now is we'll put the bottom back on. We'll put the case back on it, and we'll fire it up. We'll throw caution to the wind with this one. We'll just plug it in. We'll switch it on, and we'll see what happens. We'll tune for maximum smoke. And hopefully it will work. Now let's get this to line up. It's about there, I think. Let's get the first screw in. It's not so bad. It's just getting that first one lined up. Go on, get in there, you little bugger. There we are. that one in. I've only got 2 more to put in now. Right, and I think we're not going to put the back on. We're not going to put the rest of the cabinet on because I want to watch the valves and I want to make sure nothing flashes over or there's any distress, or if I do see smoke, it's quite nice to see where the actual smoke comes from. So we're safe now anyway, with the bases on. We've got a nice new mains lead on it. Let's see what these things are infinitely selectable on voltage now, and they have to have an accurate input voltage. Now I know that we're closer to 240 than we are to 230 here, and this is currently set to 230. So if we move that plug over like that, that's 220 plus 20, so that's 240 now it's set to. This can run on just about any voltage, 110, it'll run on 100 volts. It is nice, basically, no matter where you are in the world, pretty much I think you could get this thing to actually work. Right, so we're set to volts, we've got mains is off. That's our new terminal down there. If we look, that's what we've replaced. Let me zoom you in so you can have a quick closer look at that. Like I said, the only difference is that that's now black instead of white. If I had more time I'd just swap them over, but it's a bit of a hassle to do, especially how much varnish is on them threads to get them screws out. But at least that's safe, that's going to work now. So let's plug it into the mains. The mains plug switched off. We've got the mains off on here. We'll turn the control right down so we're not actually showing anything. And what we'll do is we will hook it up to a voltmeter. We'll test the low tension side first, I think. I'll bring the voltmeter into shot. Yeah, I think you can you see that there? Yeah, you can see that there. What we'll do is we'll test the low voltage side first. Hopefully I can get these to make a good contact. We'll have to make some cables up with spade connectors on. And we'll see if we get our two 3.15 volts out of here. Then we'll see if we get our 6.2 volts out by 6.3 volts, sorry, by going across them two connectors. And if that's all very well and good, we'll hook up some high tension to HT plus, HT minus, and we'll see whether we can get some high tension out of the thing. So let's switch on. And let's throw the main switch, and this is where we get a big flash and a bang out of it if there's something majorly wrong with it. So let's switch it on. I can hear nice transformer buzz. The power lights come on. Let's see if we've got a voltage being seems to have come up to, what, about 400 volts, and I don't know whether that's right or not. That's without me touching the controller or anything. It's come right up to about 400 volts on here. And I wasn't expecting that. Let's try flicking this over to milliamps. Let's ignore that for now, and let's just see if we do have our low voltage coming out of it. So we should have, yeah, 3.3 there, 3.3 there. Hopefully we should get, what, 6 point something. Should be close to 6.2, 6.3, but it was slightly over that because it's off load. Yeah, about 7 volts, but that is off load. I can't really go much higher on the tappings actually, it's on its maximum tapping, but so that's definitely working. Now let's, I'll switch off actually, seeing there just seems to be an issue here. I'm going to connect this. We'll go on the 500 volt scale, which is the maximum this meter actually goes to. And we'll connect up to high tension, plus and minus, like that. And we will see what we get out of the actually out of the machine. So let's switch on. Obviously the rectifiers have to warm up again. And it is showing about 450 volts now, which will go higher if I adjust that. Now this at the moment should be on 0 volts, so we definitely do have a fault with this, which I mean is fair enough. It is an old piece of equipment. It is probably getting on for close to 60 years old, so actually we've actually got something to fault find. I don't think it's going to be in this video though, because I've actually run out of time at the moment. I'm off in about half an hour or so to go and pick up some other interesting little bits of vintage junk that I've just picked up on eBay, which I might do a quick video of when I get back here later this evening. But we'll call this part 1 of this HT power supply repair, and hopefully I might be able to find a bit of documentation on it and we can actually find out. I'll switch that off. That decays nice and easily, so there's obviously some bleed on there as well, which is good. Nice unit. Obviously we are going to have to do some repair work on it, because with that crank right down that should be at 0 volts, and it's not. So we'll look into that in part 2 of this video. So I hope you enjoyed that little video. So thanks for watching and goodbye.